So let's talk about the shift 2D grid. So you're given 2D grid size n by n and integer k. So integer k represent how many times you want to shift your grid. So this is a constraint that basically that you want to keep going the next one, right? So if you are on the last one, you will shift to the 0 index, and then yeah, if you are the edge of the corner, the column, you're going to shift to the next row and then first column by using this constraint. And the number of operation for k times will be your result of 2D. So this question is pretty challenge, and if you follow this pattern, like you might not be able to solve it because you are bound with this logic. But what happens if you think about this? Like we starting at 0 position, right? However, we need to look at the k, right? So k equal to 1. So we need to shift right 1 times, and then 9 will be the 0 index, right? So we need to find where is the corresponding index at the original 2D. Then we will keep increment every single time, and then you will follow this pattern. So you're starting from here and then go right and then come here, and then this guy will come back here, and then you keep going and then come over here, and then you keep going, and then you will basically resolve this. Alright, so we need a new position. New position is going to be representing the new grid index, and we need like the index position for what? For the original 2D, right? So when we increment over the the last index, is going to be m times n, so it's going to be what? 9, right? If we hit the 9 index, you want to start from 0, right? And then there's no 9 index, it's going to be 8 index, but whatever, it's going to be the last one, and then you want to starting from the 0, right? You want to start from 0, we need to use a mod. So here's the thing that you need to be aware. So yeah, let's just stop coding, and then let me explain why I'm writing a code. Result equal to new array list, return result. Okay, and then I need to initialize my n equal to grid.length. Yeah, so here's it. So sometimes people use n by n or m by n, doesn't matter. I don't mind which one you use, but I do follow what I like. Alright, k, so k can be what? K. So k can be greater than the grid. So if k equal to, so imagine k equal to 12. So which means you want to shift 12 time operation to the right? So from here to here, you shift 1 time. Alright, from here to here, you shift 2 times. 3, 4, 5, 6, 7, 8. And then you shift 9 times, it's going to be original metric, right? So we can tell that we want to say, okay, if k equal to 12, we want to update k equal to what? 3. Because the one operation shift doesn't mean anything. We want to shift the remaining k. So if we want to reassign k equal to what? K mod by the m times n, right? So you will get a remaining k, and here we go. Let's start k equal to what? K mod by n times n. Alright. Now we need to find out where should we start it. So we need to say for in I equal to 0. Actually, let me starting from you know, in I equals to 0, and then we using a value I less than m times m. So this represent how many this represent the index, right? You started from 0 and then blah 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 blah, right? Like how many iteration you want to traverse, right? And then every single iteration you want to know, you add a new row to the list, which is going to be result, right? So it's going to be what? List of integer, and then I'm going to say row equal to new array list. And then how many element we need to add into the row? It's going to be what? 3. And in this one we add 4 for each row, right? So it will depending on your column, right? Okay, the game is not finished yet. Like, you need to keep looking for something. We still haven't assigned the new index. I mean, sorry, it's not a new index. So the new index is going to be what? It depending on this guy, right? So the arbitrary k value index. So if k equal to 1, we need to find the corresponding index, right? So in this case, we want to target 9, right? So give me one sec. So here's it. We need to find out the starting position. So starting position we need to initialize, because it's not going to be, you know, I mean, it's not going to be the last index every single time depending on your k, right? So it's going to be star equal to what? The m times m minus k. So what does this mean? Look at this. This is index base index 1, and k is also base index 1. So 9 minus 1 equal to 8, which represent what? The last element in this case, right? So in this case, k equal to 4. So 4 by 4 is 16. 16 minus 4 is actually what? 12. So this is original metric, and 12 is something right here. 12, right? And then we want to put the 12 at the beginning index, which is this one, and then this is how it is, right? All right. This is starting index, but we need to find out every single new index for the original metric, right? Starting index is not going to change, but when we increment our I, so here's it. This is the starting index, and every single I increment, right? We will get a next value, right? We will get a next value. We will get a next value. We will get a next value. But we only traverse how many times? M times. M represent column. So 1, 2, 3, and then you will break out the for loop. Then you add the result. Sorry, add a row into the result. Right here, right? Add a row into a result, and then we regenerate our new row, and then this will be the first index, second, third, and next one, first, second, third. So here it is. So result.add row, and then our position is going to be what? Is going to be equal. Okay, this should be j, should be j, and then it's going to be I plus starting, and then mod by m times n. So this is going to be the position corresponding to the original metric. And how do we add? How do we add the result value? It's going to be row.add. We're using the original grid. Position divided by m, because this is how many elements inside the m, and then this is going to be position mod by m. And if you notice that it should be straightforward, you know, position is going to be, you know, this is going to be 8 divide 3 equal to 2, so you will get 0, 1, 2. So the third row, and this is going to be a multiplied by n, a multiplied by 3, 2, the second column, sorry, the third column, right? The column 2. So row number 2, column 2, and yeah, so this is a little bit challenge for sure. Oh, memory resist. So if you notice, I didn't increment my I, right? So how do I increment my I? Is based on the position, right? So it's gonna be I plus plus. And what else do I need? Come on, okay, yes, okay. Ooh, alright. So a little bit update, you know, the coding update is gonna be this guy. So I reinitialize my I equal to 0 at the beginning and I less than n by n, and then I don't increment my I in this for loop, but in this for loop. So this is just a little bit open bracket, and here is, yeah, it's gonna be the same. Alright, so let's talk about the time and space. So this is a space. How many elements? It's gonna be m by m element, right? So the space is all of m by m, and how many time you iteration the grid is m by n. But each time you will you increment your I in the inner for loop. You're not traversing all of mm right here. You are actually traverse all of mm right here, because this is how you increment your I, and this one is going to be represented like while true, right? We initial our I, and this is a boundary. While true is going to be a while I less than n times n, and then you increment your I in the inner for loop. So this is like the major for loop. So it's going to be all of m times n. You want to traverse this number of time, right? Until you break out this condition. Okay, so time and space are the same, and if you still have a question, leave a comment, and I'll see you next time. Bye.